My name is Seth Law. I'm the VP of Research and Development at nVisium. It's an application security consulting firm. We do everything from application penetration testing, whether that's web applications or mobile applications, to source code analysis, to code remediation and developer training. The whole staff at nVisium, we're all ex-developers, and we are developers, and are focused on application security. Obviously, you can read some of that up there. I contributed to multiple open source projects that we have that we're running out there. You can check our GitHub page. I've been an application security architect. I actually cut my teeth doing Java development at iOmega. Does everybody remember iOmega, the zip drive people? Yes, I was not responsible for the click of death. I'm going to put that out there right now. That was not me. I was more on the web side of things as they were building their web presence. But that's where I got my start, coding. More recently, I do more in the hipster languages, right? We do assess quite a few .NET and Java applications, but a lot of research and activity is in Django and Node and all these other new frameworks that are coming out because, surprise, surprise, security isn't built into them, or we don't know as much about them as we do the older languages and frameworks. I'm also a soccer hooligan. I love to talk about soccer and what's going on with Chelsea this year, or even MLS. I like to support that. So if you want to have a discussion over beers later, we can. But it doesn't apply too much to the discussion today. All right, the first thing I want to talk about has to do with this string of characters. Does anyone know what this string of characters is? It's not SQL injection.
They look like emoticons.
It does look like emoticons.
Does it bring down some system?
It does bring down a system. This is a denial of service attack. Does anyone remember shell shock from last year? This is the string that you could send to Apache web servers, and it would cause the systems to overload themselves, right? It would just spawn a whole bunch of shells, basically, and take down the system. Now, the interesting problem that we encountered with shell shock is who's responsible for that vulnerability? Right? Is that your developers? No, most likely not. It's the Apache's developers' problem, right? Because they're the ones that coded the application in such a way that it would accept these variables and it would spin a shell on the back end, and it was basically a command injection vulnerability. But we have this strange problem when it comes to application security, because applications are not just the code that your developers write. If you think of your web application, it is a holistic system of different technology components that serve up functionality to consumers or to the intended parties, right? So just limiting your security program to your developers or one phase of the development process is something that's going to bite you in the butt, is really what it boils down to, right? So we have all these different technologies that exist, people that are involved with serving up content and functionality that your developers depend upon, right? And, I've got examples like Tomcat and Sans has a list of vulnerabilities, Rails. There's just there's multiple different parties that have a say in how secure your application is and how secure your environment is. The more that you think about an application, you've got to think about the full stack that is involved with that application to serve up the functionality to anyone or to the intended parties, right? So let's take a quick poll before we move on. Who here has a dedicated security team in their organization? Right. I mean, most organizations have at least one or two people that are dedicated to security. Now, what about application security? Anyone? I know Apple does, right? Now, and this is pretty common, right? We talk about security, and it's a pretty well understood field. We've been dealing with, firewalls have been around for a long time.
But once we get up to the application security layer of the OSI model, or the application layer of the OSI model, it kind of falls apart because there are so many technologies, there's so much new, I call them the hipster languages, right? There's the new hipster languages, there's the new frameworks that are out there that we don't understand how security affects those products. And so it's, the talk today is it comes down to two things, right? People versus technology, where we actually place security within our organization to secure those applications. In general, what we're looking at is, Terminator versus your security staff or your developers or something along those lines that's trying to catch these security exploits and the attacks that are going on against your organization you're trying to catch the exploits as they come in to remediate them or to stop them from happening. So we're gonna step through the OSI model and talk about a layered security approach, right? At the bottom, we've got physical security. This is very well understood. We run into quite a few organizations where the CISO is an old guard, right? A physical security guard who happened to be around when they created a security position at the senior level in an organization. Now, this doesn't always fit with the new attacks that are coming around, right? Great, we know how high to build fences to make sure that people can't get in, but then we basically open the back door as far as the internet goes and the network that's connected to it to attack an application. Hence the reason that we built network security products and we started to deploy them, right? Your IDSs, your firewalls, those that would detect attacks, that block ports, that make sure that you are protected from network security style attacks. Now this still leaves holes in our perimeter that people can get through, right? We have functionality that we are serving up through the various applications and that we need to protect against attackers as well. So at nVisium, we concentrate on that application security layer, and that's where we're going to talk today. Right? Now, all right. So let's talk a little bit about the breaches that have happened in the last couple of years, right? If you go to Google, and I did this just the other day, right? I took this screenshot, and you Google security breach, it actually comes back with almost 20 million results of breaches that are out there, right? The latest that you've obviously heard about, right? The Office of Professional Management, the OPM, the government one. There was Ashley Madison that was out there. That was, where did these breaches actually happen? If we're looking at the stack from previously, right? Application security, network security, and physical security. Where is that data coming from? Any ideas?
Social engineering, it's not
Social engineering? Some of it is social engineering, you're right. At which point, they've got access to a system somehow,
so it's
right?
not even on that list.
Then it's not on this list, you're right. Yeah. But if you look at, Target, right? That was a combination of network security and application security, right? It was further up the stack. Insider threat is typically an application security problem, right? They've already got access to the data. They're able to exfiltrate it somehow, and it may even go down to physical security. They may be able to put it on a thumb drive and walk it out the door. The thing I want you to realize is most of the applications that we have, or most of the data that we're trying to protect is within an application somewhere. Whether that's an Oracle database, whether that's our internal CRM system, it depends on the organization that you're in and and what you're trying to do with the data, where that is going to be housed. But without the application protections that are in there, you are going to fall down. And a lot of these do run into the application layer. Right? SQL injection attacks are very common out on the web, and that's a big source of data exfiltration. But when it comes down to it, we're really fighting for the same dollars. Has anybody ever done a cost-benefit analysis before? Yeah, we've got a couple people that have seen this, right? If you've ever done like the CISSP, that certificate. Actually, we'll walk you through quite a bit of this. But really what it boils down to is you have to take a step back and actually figure out how much money you're going to spend on security, and then where you're going to deploy those security dollars, whether that's in the network security layer, whether it's in physical security, or whether it's actually in application security. We've walked into way too many organizations where they spend millions of dollars on some sort of data loss prevention product that they roll out to everyone's desktop, and then the main website has a SQL injection flaw in it. So what does it matter that you're protecting your against data exfiltration for employees when you're just giving it away to consumers, right? That's the sort of problem that we're trying to prevent. So to do that, to frame our discussion today, we're going to talk through a generic SDLC. Right? These are the 5 phases that all SDLCs have in some form or another. Your analysis phase, your design phase, implementation, testing, and maintenance. We step through each of these when we're developing some sort of new product. Right? I mean, I say SDLC, that could be a software development lifecycle or a system development lifecycle. But an AppSec SDLC has its own set of tools and processes that apply to each of these phases. Each phase of the SDLC has a corresponding application security process or function that we can apply to it. And that's what we're going to talk through today, is the different phases of that. Now, there are different versions of SDLCs, whether you're implementing Agile versus Waterfall, right? Let's do a quick poll there. How many of you are using a Waterfall method for software development? There's a few. Agile? Okay. How many of you are using an Agile fall method, right? I was at an organization, and not too long ago that was the big thing. It had always been Waterfall, and so development decided, all right, we're going to go Agile now, which is great until you realize that they don't control the whole process. And so development went Agile, but it still took 3 weeks to get through QA on the back end, and so it's very difficult. The whole organization has to buy into it. That's the whole continuous delivery, test-driven development process. So when you start looking at these different methods, it's very hard to fit security in, right? A 2-week Agile sprint makes it very difficult to take 40 hours to dedicate to security testing, right? That just does not match up. So you've got to depend on some sort of technology or some other process to actually implement the security during that phase. So the first phase we're going to talk through is analysis. This falls back to security versus development, right? You've got security on one side, development on the other. But what we do from an application security perspective is called threat modeling. Anybody here, can anyone define what threat modeling is? Yeah.
Identify or predict vectors that could potentially compromise the system and list them down and then also do cost-benefit analysis in the end to see and prioritize them.
Okay. Yeah. So it's the identification of threats to the system, and then doing some sort of a cost-benefit analysis onto whether or not that threat or that prevention that you've come up with makes sense for the application as it exists, or as you want it to exist. It's really just this structured approach to analyzing the security of an application, right? Number one, what am I concerned about? If it's a mortgage calculator, there's probably not a lot of risk associated with that, right? That's something that people put in and they use all the time. But on the other hand, if it's a mortgage processing system, there's other threats that are built into that you probably need to be concerned about. The process typically goes like this. You deconstruct the application. You take a look at the processes, the data, and the functions of the application as you are analyzing the need. You categorize and rank the threats. So there's a standard list of known threat actors that are out there. There's multiple papers that have come out of Microsoft on threat modeling. They even have a tool that they call their threat modeling tool that'll help you through this process. But then you try to mitigate those threats through different components of the application, right? And that's where you get more into the design phase. The tools that are involved here, Microsoft's threat modeling tool, there's some open source ones as well, Trike and Octave, that will engage you in this process as well. The personnel that you normally involve are the architects, the application owners. Developers don't need to get as involved in this phase, right? It's like any business process when you're building an application. Typically, the business owner that wants the application to be built is going to come to the table first and discuss it with an architect. There is a pretty high time investment that needs to go into it. You've got to build the process out first. And you've got to figure out what warrants a threat model inside of your organization. Yes?
In your experience, how many product owners actually know how to do all this stuff?
Oh, it must be led by someone that already has done it. Usually, a product owner isn't going to know what they're doing as far as a threat model goes. But it's fairly easy. Like there's organizations and there are white papers out there on how to step through it. But usually it's going to be somebody coming either from the security team or even the application development team, like the architects. That's who would be driving the process.
Yeah, question in threat modeling, it's just what can go wrong kind of analysis, or you take it domain by domain, how are you doing identification and authentication in the application, are you doing session management, how are you doing encryption? So it's more a domain-based breakdown, or is it just what could go wrong?
For threat modeling, you're getting more into the design phase, right? For threat modeling, typically what you're going to want to do is identify the threats to the application on a high level, right? We know that authentication and authorization is something we're going to have to design into our application. But what we're trying to prevent with that is someone spoofing another user, right? So that would be the typical attack. There's a couple of different methodologies out there. One that's called Stride. That's what Microsoft uses. And that talks about spoofing, tampering, repudiation, information disclosure. So there's these 6 different categories that they go through that are kind of the known threats to an application, and you decide whether or not that applies to your application. And then once you get into the design phase itself, right, then you start talking about the specifics of how we're going to implement and protect against that. The threat model is a purely tabletop exercise to identify those threats so that we know what we're dealing with when we are starting to build our design requirements. All right? Yes?
Just as a side note, so in different companies, what I've seen is before the architects even start with particular project, they already have the InfoSec team, if you're lucky to have one, has already provided controls,
Yes.
classification of projects, and the information. So if you're building a SAP interface to send out people data, and you're exposing it out to all applications internal versus to be shown outside, then automatically that information itself, in some of the organizations, they classify that this cannot leave the firewall, and if it goes out, it needs to be scrubbed out or probably encrypted and all this stuff. But big organizations have policy with some.
Yeah, so he's
the starting point.
Yeah, so he's saying the starting point is typically, and this is exactly what I was talking about with the deconstruction of the application. Typically there is some sort of data classification within an organization, right? If you've got mortgage data about someone, that's more protected than an employee's phone number, right? For example. So the data classification is actually going to drive the threat modeling around your application.
Just a side note again, healthcare,
Healthcare.
it's also on last, the legal controls automatically mandated.
Yeah, and he's also saying that the legal controls are also in place. There are compliance issues when it comes to healthcare data or financial data that you're going to have to be worried about. And that's where we dig into the design phase. I mean, threat modeling leads directly into this design phase. Depending on the methodology that you're using for your SDLC, it's going to heavily affect the design requirements that you build out. Right? In general, any design requirements need to be simple, testable, and transparent. Right? Easy enough for anyone to understand, easy enough for the QA to be able to test them, and QA to be able to understand what the results should be. If it's too complicated, we've seen this multiple times. You'll step into an organization, security will hand over a book to development, and they're not able to actually translate that into code. And if they can't, security has failed. And this is why we keep saying that at nVisium, we like to say that developers make the best application security experts because they know how code is built. It's easier to train a developer to be an application security professional than it is an IT firewall administrator to code. Right? It's just common sense. Right? So there's multiple considerations in this phase. Right? You've got your threat model output that's come out of that previous phase. You've got the third-party requirements, PCI, OWASP has requirements that are built into PCI. Depending on the organization, HIPAA is one that you'll have to deal with. These are all requirements. I worked at one organization that collected data from all the large banks in the US and was in turn audited by something like 300 to 400 organizations on a yearly basis. Do you know how much time that takes and how many people you have to dedicate to that? They started to throw what they called the audit festivus, right? Where they would invite them all to come at the same time and ask all their questions at the same time. Because no one, you'd say, oh, we've got a SOC 2 audit, right? And every big bank is like, no, that's not enough. We need all these other questions answered. So it can be a huge problem, right? If you're designing to those requirements, that can be a huge cost. But the one thing you have to remember, compliance does not equal security. Was Target compliant to PCI? According to the QSA, they were, right? And they leaked all that information. I mean, most of these organizations, most of the breaches that you see out there are vulnerable to all sorts of different things. Yes?
Does compliance equal immunity from lawsuits?
That's usually why you do it, right? I mean, at least at some level, Oh, sorry. Yeah, he asked if compliance equals protection from lawsuits. That's the idea behind it, but when it comes down to it, it doesn't mean that if you're in charge of a system or of an organization that you're not going to get fired or sued because you released data.
It reduces risk.
Yes, it reduces risk, but you are starting to see people buy insurance for cyber breaches.
And I think usually I think it should be compliance is equal to minimum baseline security. And this actually, I think, question should be compliance is not equal to risk-based operational security.
Okay, fair enough. Yeah. So compliance is not equal to, is not equal to risk-based operational security, but it is equal to the minimum set of security regulations that someone decided are relevant, right?
People give compliance a bad name, but I think if there was no compliance, nobody would do anything.
Oh, I'm not arguing it, right? I mean, PCI has actually changed quite a bit in the financial space because they've forced a minimum level of security and actual scans and things to go on. Yes?
Yeah, I mean, I work in a compliance-oriented area.
Yes.
And the way that I put it is, compliance removes stupidity. That's all it does.
Very much so.
Removes stupidity.
But it doesn't ensure security, right? They're two separate things.
Security just removes all the stupid things that people do when they build an application and deploy it.
Yeah.
And so you can get rid of all the things that you should be doing, and you can hold up to your boss and say, this is what we have to do as a minimum, and it's going to cost us. And you can't argue anymore.
Yeah.
The point is to say, this is what we have to do.
Yeah.
And there's no more argument. When you get into arguments about philosophical arguments is how you should implement it and how far you should go. And that's a business risk analysis problem that you're addressing here.
Yeah, exactly. Business risk analysis. Good.
So I was wondering how you dealt with problem or analysis of risk insurance when you're dealing in the case of there are unknown unknowns. So in the last year, we had some security problems with Bastion, something that's been being used for over a decade.
Yes.
Right? And it took them about 6 months for the rate of bug fixing to finally drop down to its historic level. So they didn't get it right the first time. So when you're doing your analysis about risk stuff, how do you talk about, 0-day, unknown unknowns, and what is the appropriate interval to go back and reestablish your assumptions?
It's a fine line to walk, right? It's hard to, the unknown unknowns are what you cannot protect yourself against. That's really what it boils down to. What you're trying to do with programs like this and with the security, what we put into place is really you don't want to be the low-hanging fruit, right? That's really what it boils down to. Getting rid of this stupid stuff so somebody can't do a drive-by SQL attack and take all of your data, right? That's really what it comes down to. And then everything else above that is trying to get above what everyone else is at. But the unknown unknowns, the 0 days, a dedicated attack against your organization is typically something you're going to have to detect for so you can pull the plug. That's the only way to protect against it.
Okay.
Right? Yeah. All right. So next, along these same lines, talking about compliance not equal to security, I want to talk about a Google Trusted Store. Has anybody dealt with a Google Trusted Store before? All right. What is a Google Trusted Store? Have you seen that logo?
I have. Basically means that they run a certain amount of testing against it to say that there are no known vulnerabilities against that specific implementation.
Oh, yes. So you're saying that it meets a minimum level of compliance to Google's list of security issues. Actually, all it says is that they will take your product back without question. That's the only thing that you have to certify to be a Google Trusted Store. We went and actually looked at Google Trusted Stores. Like we did an analysis of, I think it was about 100 of them. Half of them didn't even use SSL for most of the site. They might, like during the ordering process, but even then, the SSL versions that they were using were out of date and not compliant with the latest standards. There was all sorts of things with cookie issues and cross-site scripting, the common web application vulnerabilities. The only thing that this was is they gave money to Google and basically said, yes, this is the return process that you follow. So you as a consumer can trust that if you buy from us, that if you return the product, we'll give you your money back. That's really the minimum level. So just because it has the Google's name on it doesn't mean that it is secure, right? It's like anything else. You've got to know what else is there. There's other things that are out there. There's like a McAfee scan. This store is McAfee secure, and it's the same sort of thing. What they do is they scan the site once a day and basically look for this minimum level of security effort. Make sure that Apache is up to date and like 10 different things, but it has nothing to do with the application when it really comes into it. They're not checking for SQL injection or cross-site scripting or the common OWASP top 10 vulnerabilities. All right, there is one more thing that I wanted to talk about in the design phase. All right, this is the fact that when it comes to anything outside of security, I'm an idiot. And outside of development, right? There's all these different technologies. I've got a lot of domain knowledge when we talk about Java or Node or Python, but anything outside of that, I'm an idiot, right? But I hate to break it to you, so are you. That's what it comes down to. So at some level, we need to train people about the issues that exist. Right? It's not helpful for us to hold people to a standard when we haven't told them what that standard is. We can't expect them to prevent SQL injection when they don't even know what the term SQL means, right? And there's multiple ways that we can go about doing this, right? There's in-person trainings, online CBTs. The most effective ones are those that are recurring. So you're training your developers on a yearly basis or when they come into the organization, but giving them refreshers about new vulnerabilities and new security issues as they pop up. It must be customized to the audience. I mean, the developers are going to get a different level of security training than someone on your security team or your red team that's actually doing penetration testing. You've got offensive security versus defensive. So there's all sorts of trainings available. Make sure that you're picking the right one for your audience. Okay, so let's move on to the implementation phase. I know we're running a little bit over here, but we'll finish it up. This is where the fingers actually hit the keys and we actually start writing our code. You've got to ensure at this level that the code meets the design for security compliance. And from an organizational perspective, like when we're developing an application, we need to start thinking about security as a feature and not as an add-on. When we think of it as an add-on, it gets bolted on at the end and it's never as effective. Like the whole reason that we're talking about this is we want security built into the application so that it protects against attackers before it is deployed and before it gets exploited. It's easier to protect against it than it is to clean up after the fact. At this phase, there's multiple different tools that are out there that can provide us with some sort of automation to check for security vulnerabilities. IBM has what they call AppScan Source, which will scan code for vulnerabilities. HP provides Fortify, if you've ever used any of these. Yeah, I mean, does anyone have familiarity with source code analysis tools? All right, quite a few actually. So tell me, how effective are they?
False positives.
False positive hell. I'm just going to put it out there, right? That's what it is. They do a really good job of identifying like regexes. They do a source to sink trace through the code. But every time I use one of these tools, it seems to be I spend more time getting rid of false positives and determining what is a false positive than I do actually fixing the code. It's no fault of the tools themselves because there's just a lot of code to comb through. It does focus my efforts in certain areas. It's able to identify things like, hey, you're using MD5 when you should really be using bcrypt or something along those lines. But it does take quite a bit of effort.
Question?
Yes?
What about open source software, different Apache systems? Does that ever go through some kind of source code analysis for security?
They do and they don't, right? HP actually, or Fortify at the time, actually started a project to scan open source software. But once it got acquired by HP, the Fortify team, they actually kind of stopped that effort. I think they just didn't want the liability associated with that. That doesn't preclude you or anyone from taking these tools and actually scanning that software, but no one really releases those results.
Bummer, I don't want to do it.
Yeah, I mean, it would be nice to see, but there are things out there like Find Bugs for Java has a, Find Security Bugs plugin that'll actually go and scan things. And I know Philip, the main developer on that, has actually been scanning code, and then he'll like put bug reports in for different software. But that's only for Java, right? You've still got C and C++. So, I mean, there's still some community outreach that needs to happen there.
So my personal experience is any Apache product which is not in incubation, they take these bugs very seriously. Yes. But anything that's in incubation, we have to take it with a pinch of salt. That there might be something that they're still working on. The second thing is, most of these tools are good for a limited scale. At scale, they have a lot of issues. Like I've heard stories of scans running for 40 hours, and nobody has got a result.
Yeah.
And people are impatient, and like another major pain is most of these static code analysis, the time given to information security team, very limited. The developer is ready, they want to ship the code, and everybody right from executives are on top of security head saying this needs to go out. Why are you guys holding up? Well, that's because so many lines of code, so many open source linked software is there, and we are scanning, and the scanners are like taking the time.
Yeah.
So,
And that's where, us having security separate from the development organization is actually a very bad thing, right? If you're going to use a scanning tool like this, it needs to be in a continuous deployment model, right? The developers have to get used to, hey, guess what? I've got a tab in my IDE that's basically, hey, I'm going to do a Fortify scan on this code right now, right before I even push it into the source code tree or anything along those lines. And that will actually prevent that problem from occurring because they've already scanned it, they already have the report available. If someone in security needs to review the report, great, but at least that check has already happened. It's when we see that separation that the problem occurs.
Talking about the verify step, what about code reviews?
What about actual like manual code reviews? I do have a slide in here in a minute that we can talk about that, but it falls back into the whole, are you a part of the development team or are you a part of the security team, or are you bridging those two worlds? Right? If I'm part of the development team and I'm actually in there on a daily basis, I'm going to be sitting in those code reviews, right? And I'm going to be looking for my security requirements to see if they're actually met. If it's passed to me 2 hours before they push it live, it's going to be a lot harder to actually catch any vulnerabilities. Yes?
So, are you a fan of code coverage metrics? So that, because some part of testing for quality or security is in fact detecting security error conditions.
Yes.
Right? And so, although I'm a great fan of source code analysis, I was wondering if you also believe in dynamic testing and dynamic testing.
I do, and that's the next phase that we'll talk about, is the dynamic testing that occurs. But the code coverage metrics are, I mean, anything that's looking for quality assurance should also be looking for security. That's really a measure of quality assurance, is the security test. We should be designing security tests in this phase to look for these conditions, the input validation errors, right? It is all some sort of a quality assurance metric that we are dealing with. So I'm a complete fan of, putting security into every step, and code coverage goes along with that. The dynamic testing needs to happen as well.
But generally code coverage, that's in John Deere, when I was in John Deere, we used to do a tech debt iteration.
Tech debt iteration?
Every 8 week, we had 8-week period broken down into 2-week iterations. And the last iteration will always be a technical debt, where we would do the code coverage, and debt code removal is the first top line item.
Yes. So removing the dead code.
Removing the code and having 80% to 90% coverage almost all the time. So that's a tech debt thing.
Yeah.
Well, I mean, but again, it was built into the SDLC process, right? You knew that, hey, the first 6 weeks were all about new features. The last one's about, all right, we're going to go back and make sure that everything is removed, everything is cleaned up like it needs to be. Right? Yeah.
What if your application is about 80% libraries that you don't have the source to?
Then we're actually going to dig into more of the testing phase, right? Instead of implementation where we're writing code, we're going to be looking more at the dynamic testing that's happening and what we can send to that, right? I mean, if I'm designing a security test, I should be testing those libraries as well. That doesn't mean you're going to test the complete library, but at least those functions that you're using need to be flushed out, right? What happens when I send strange input to it? Does it crash the whole system, right? It's those edge cases that we need to be worried about. The thing that I want you to remember here is there is no silver bullet, right? Even though these tools scan and they find certain things, they do have limitations. They have false positives. There's certain classes of vulnerabilities that they're just not going to detect, whether that's business logic problems, whether it's authorization and authentication issues. Some of those things will only be found manually, either through an approach where we're digging through the haystack, right? You can't almost see it, but you're looking for the needle in the haystack. You're sitting in a code review with the people that designed that portion of the application or implemented it, and you're going to talk about these issues because it's part of the security requirements that were built into the application initially. If you don't have any security requirements, it's almost no good to sit in the code review because you have nothing to call back to say, hey, we told you that you should make sure that passwords are at least 4 characters long, right? Okay, 4 characters isn't long enough, but you get the idea. At this phase, you're dependent on your architects and your developers. The organizations that seem to do best with developing secure applications actually don't separate out security from development. Right? They have embedded teams. They identify developers that are concerned about security and train them up and make sure that they know what the process should be. If we don't do that, the security is never going to get built into the application, is what it boils down to. All right, so let's talk about the testing phase, automated versus manual, right? All this is about is finding the security flaws. Really, you should be involving the QA organization in this. If you have QA, right, give them a set of test cases that are security specific. Test every function for security, right? Throw the input at everything that's there. it's active, right? At some point, it's really beating the application until it chokes. You can do denial of service testing. It's very easy to do, but most applications are going to choke at some point. It's whether or not that's actually above the threshold that you can live with. You're going to run static analysis at this phase as well, right? Sometimes you have discrete developers that are doing different portions of the application. You got to be able to see what it is holistically when you have the whole application sitting in front of you. Source to sink analysis, but dynamic analysis, right? You've got your, you've got all these multiple different names for dynamic analysis. Dynamic testing, I talked about application security assessment, application assessments. So the security industry in general has done a bad job of branding dynamic testing of applications. We have all these different names for it. We have all these different tools that are available that we can use. Some of them will work against your application, some won't, right? You've got IBM has AppScan, HP has WebInspect. That's all part of the Fortify team now. Skitfish from Google that'll quickly test in a web application for XSS and other vulnerabilities. Portswigger is the Burp Suite Pro is what they call it. There's it's a less expensive option. That's what we use as pen testers quite often. White Hat has a scanner, an application scanner. So all of these different tools are available to you. It just depends on what your organization can actually implement into that SDLC, right? If you don't have someone that is dedicated to running AppScan within your organization, it's going to be very difficult to apply that across the board and implement it so that it is effective for your organization. Whereas, Skipfish is just an online command that you can run. That's a lot easier to script up during your development phase than AppScan happens to be, right? So it just depends on what your threshold is and how much money you have to put towards this. Again, utilize those QA tools instead if you can, right? Build the requirements, build actual tests that can that take that as an input rather than going out and purchasing a separate tool if it's available to you. The considerations here, manual versus automated, the cost involved, I kind of talked about that. The impact, right? How long does it take to run these tests? QA usually does a good job because they are involved in the process so much. So, I know I'm harping on that a lot, but we don't see enough of QA involvement when it comes to security testing. Timing and effectiveness, are you making sure that you catch all of the vulnerabilities or just the ones that you're concerned about? You got to remember that not all penetration tests are created equal. If you've got a junior intern that's responsible for checking your code for security, they're probably not going to catch as much as a senior level developer that knows the application inside and out. That's really what it boils down to. You can go out and you can hire somebody like us to come in and test, or you can build your own internal testing team. Either way, training falls into it, right? Those people that have experience with SQL injection are obviously going to be able to find that easier than someone that doesn't. Okay. All right, any questions? We're on to the last phase here. I know we've been going for a while. Yeah?
If you're looking to hire somebody to do AppSec testing, what are we looking for?
Like I said before, you want a developer with security experience, right? You can go and find someone that has like the offensive security or the offensive certified security professional, right? OSCP, I think is the name of it. But that is more of a network focused test. Most of the time, if you're going, let me step back. Are you asking about hiring someone to be internal to you or an organization?
Kind of both, but typically if you've got a somewhat large application, you probably want to bring that person in-house because the cost is going to be significantly less over time. If you've got a small application, you've got 2 or 3 developers, you might just want to hire it out even though it's going to cost you an arm and a leg.
Yeah.
You can't keep that person busy, all the time. But the qualification question goes to both hiring somebody, what's their data, and what are we looking for as far as qualifications beyond being able to write code?
Okay, beyond being able to write code, it's someone that, number one, they're going to have to be passionate about security, right? Typically some sort of training. There's like the CEH, like the Certified Ethical Hacker, or something along those lines besides being a developer, which means they've got that offensive mindset, not just the, hey, I'm cranking out some functionality and writing it. The other things then I would start to get into more specifics of, hey, what language is it, right? Do we need someone who actually knows what Spring Security is, right? Or Node or whatever it is, right? If the organization that you're looking at only tests COBOL applications, it doesn't make sense for you to throw them at a Java web app, right? So there's different organizations that are out there. Sometimes you run into the big security VARs that they'll claim that they do everything, but it really depends on the people that they have on staff. I'd ask actually, hey, what are their qualifications when it comes to my specific technology, right? SAP is a different beast than Oracle is, right? So all those sorts of things start to play into it. Okay. Did you have a question back there?
Sure. I wanted to follow up on your definition.
Okay.
I wanted to know, when you said I want a developer who knows security, when I'm hiring somebody for app testing, I wanted to know, did you mean a test developer or did you mean a product developer? Because, there's this boundary area between AppSec testing and regular QA, and you've kind of been dancing around the boundary. If you could clarify that boundary a little bit, I'd appreciate it.
I would lead, okay, that's a valid question. So you're asking whether I'm looking for a test developer or a program developer, right? When it comes to hiring an application security professional. I would lean towards hiring a program developer that has a history of actually writing test cases for QA to test, right? So I'd say both, yes, yes. But if it came down to it, I wouldn't be opposed to hiring or training up my QA test team on offensive techniques, right? Hey, let's give them a list of SQL injection strings that they can throw into their load tool to see if it actually causes some problem with the application, right? That's not going to hurt anything. But again, you still have to give them some sort of training on what it is they're doing so that they can tell the developers what the issue is when it comes down to it. So, okay. All right, so finally, we get to the maintenance phase. This is the last one. Really, this is the one where we're like, oh no, we're not done, right? I delivered my application and still there's something that we have to do. At this phase, you really have some sort of proactive versus reactive control, right? You've got to take a layered security approach at each of the OSI layers to prevent bad things from happening. So if this is our OSI model again, you've got different preventative controls. So you've got your doors and locks, right, on the physical security layer. You've got your firewall, your intrusion prevention that sit in the network and transport session layer. And then you've got a web application firewall that sits at the top. But that's not going to prevent everything from happening, right? So you've got reactive controls that you have built somewhere along the lines, right? Cameras, motion detection, network event monitoring, intrusion detection system monitoring, and application logs. This is where we see most organizations fall down, is they don't actually take those application logs and do anything with them. The developers look at them when there's a problem, but we don't monitor those logs for security events. But it should be some sort of security event monitoring across the board, right? We get a feed from the cameras, but we also get a feed from the authentication system, so we know that, guess what, the admin assistant just logged in from Asia. Right? What's going on, right? There should be some sort of a preventative system built into that. Or a reactive system, I should say. This phase is all just about defining the process, right? What's our incident response? How do we actually watch for things? What does the SOC or the Security Operations Center do when they get an alert from the cameras or from the authentication system? How do we actually patch that? Or how do we notify the developers? I know we all hate to hear it, but at some level, somebody has to be on the other end of that, right? If the SOC gets an event, they've got to be able to call someone up and say, hey, I noticed that Judy, the admin, logged in from Singapore, and we know that she was here today. What should I do? And that's either got to be a developer or somewhere along those lines that answers that call to give some sort of background and actually fix the problem. So my conclusion on all of this is, security is hard, just try harder. I mean, really, that's what it boils down to. the harder that we try, the more thought that we put into it, the more protected we're going to be. All right. So the summary that I've got here, and I will send these slides out, is each phase of the application, each phase of the system development lifecycle has an application security component that should be built into it, right? Whether that's threat modeling, security training, source code analysis, some sort of a dynamic scanning tool, or some sort of a process that needs to be built into place. All right. Any other questions? I know I've been talking for a while, but let's start right here.
Are you familiar with binary code tamper-proofing? And if so, can you talk about that a little bit?
So binary code tamper-proofing. So similar to what Android does, or is that what you're asking?
I'm talking about techniques like runtime application self-protection.
I am. I don't know if we can completely get into that. Right? I mean, that's really on the maintenance phase, right? If we release our application to the public, there's things that can go into that to protect it against manipulation, right? So Apple does this when they release something from the App Store. They typically encrypt the application before it runs on the phone. And if it's not signed by Apple's key, you're not able to decrypt the application and run it. Right? That's what the jailbreak process is all about, is breaking that encryption layer so that you can run whatever you want on the device. So, I mean, there's specific techniques that go into that. It is effective, but then it becomes more about the management of the systems and the deployment model than it does the actual development of the code. But even in those applications, we see the same problems occur, right? If there's input validation errors, the phone itself still has to decrypt that and run that application. So it could be handling that data improperly. There still could be SQL injection in it. It doesn't preclude you actually doing any of these other steps.
I think like the three things. One would be like the obfuscation, reverse engineer. Second would be like having something within the code,
right?
So that if there are any exception conditions and known behaviors, then basically you have at the code level. And I think third thing would be, I think, like sensors. I think was for the sensor project, in which you can insert the sensors within the code, and then you can report on them. I don't know much about it, but that's what I've heard of them.
Okay. Yeah. So we're talking obfuscation. We're talking, what was the second one that you mentioned? Inserting libraries within the code. Okay. So inserting like detection within the code for manipulation, and then detection on the server side, like the OAuth sensor project, to actually detect those attacks. Yeah, I mean, all of those we're talking about the maintenance phase, right? We're talking about, we've got an application, we've developed it, and now we're putting reactive controls in place so that if something happens, either the code can self-correct itself, or something behind the scenes, like the server will know about it and it will notify someone.
So just to add on to this, right? So between the final completion testing and the way you are laying it out, right? You're saying the development is separate, testing happens, and then maintenance. But of course, most of us are doing CI/CD, so which means that daily we are developing, and daily we are testing, and daily we are deploying.
Yes.
So this is not a clear boundary. It's like totally amorphous. So it's totally seamless. Every day these things happen. So what, particularly the recent developments like containerization, like you have Docker. So earlier we used to have dedicated servers, QA farms where we used to run our QA build. Yes. And then like test cases would be run on it, then the build would be certified, and then we'll push the same thing to a UAT, and then to prod. But these days we are talking in terms of container. So one commit goes to Git or SV, and then from there it goes into a Docker container. And that same image is pushed across multiple environments, right? So which means that some organizations I've seen, they use tools like Cucumber, Fitness, and then they put it on Jenkins. Yes. And they run all their security test cases on Jenkins. And then they hope to catch things like, okay, is the application doing the right thing? Like if I execute a negative test case, is it able to react to that, either by way of giving exceptions or shutting itself down, something like that. But very little focus is given there. But this Docker diagram kind of things are very hard to test for those kind of things.
Well, It is. So are you saying specifically Docker, like containers are hard to test for security, or the code that's deployed within it?
The code is, of course, very well within our control, but ultimately when we give it as containers, it is going into Amazon Web Service Cloud.
Yes.
Right? Now, your QA team basically has to do the same infrastructure that they do the prod now against the test Amazon Cloud on US East or whatever it is. But then they are totally clueless. Are we really testing the right container or not? They are not able to tell, right? Because
So you're saying that the containerization and the wrapping of the code in this package is making it more difficult to test because so your test team, like your QA test team, just doesn't have experience with it. Right?
Absolutely, you need a far more sophisticated. Again, a developer has to be called in and say, "Can you write some harness for me so that I can run my test cases against these containers?" Hey, first of all, is this container really mine? How do we even verify it before doing it? These are additional things actually, so it's no longer this simple.
So what he's saying is it's no longer simple, right? It's no longer this waterfall method that we've had for years and years. Nowadays, we've got these Docker containers, we've got other, vagrant images that we deploy code to that also introduce security issues and security tests that may need to be written in addition to the normal tests that would go into testing the functionality of an application. It is something you need to keep head on.
You mentioned about security monitoring, right? So there are several tools out there like HP ArcSight, IBM Curator, and Splunk is building something, Sumo So do you see they haven't completely addressed that problem? And where do you see, these things to be improved in this?
They've typically built an infrastructure. So he's asking whether or not the monitoring tools that are out there have addressed this problem. Typically, they don't take it head on, would be my answer. They give you, hey, here's an API, and you need to feed Splunk using the Splunk agent that's on a box, and we can push the application logs to that. But then you still have to write your Splunk script on the back end to actually call out, all right, we know this is authentication, we know this is an error, someone's trying to log into this account because we've seen 100 failures within the last 10 minutes from this specific IP address, right? So you've still got to put in some level of effort to identify that. And the nice thing here is if you followed this whole kind of application security SDLC, you've got some sort of a threat model that you built up front and you know that, all right, we need to prevent somebody from logging in from the wrong location. Right? You can build that in at the end if you've got the security requirements built up front. And then you're not as dependent on what they give you, but it is a custom implementation at that point. All right. Oh, one more in the background.
With all the code analysis tools you put up there, which one would you recommend?
Which one would I recommend? Manual. No. I jokingly say that, but you're going to catch more with manual than you'll catch with any of those, and then you won't run into the false positive issue. I've had the best luck broadly with HP's Fortify. It supports the most languages that are out there. But some of the others that are specific to like Rails, there's the Brakeman Pro that's out there for Rails applications, does a much better job than Fortify does because it's developed specifically for Rails applications. I hate to say it, but it depends, right? If you're going for a wide array of products, Fortify is going to be the best, and then AppScan Source right behind it, because they do everything from Objective-C and iOS applications to .NET and Java applications. Whereas some of the others, like Clockworks and others, they do really well with C and C++ applications, better than kind of Fortify and AppScan Source do. But then they fall down in other areas because they don't support as many languages. They don't have the engineering talent to do everything across the board. So. Short answer, manual. Otherwise, it depends on what you're trying to accomplish.